All right. So today's lesson 5, we're going to deal with angles of elevation and depression. Okay. I'm going to really simplify down the definitions for you. So don't worry about writing a whole bunch of stuff. But when we start talking about elevation and depression, the way these ones are set up is these are like actual real world example type things. So when surveyors are actually trying to figure out how tall something is or how wide something is, okay, what they will do is they have their fancy equipment. You've ever seen the guys like walking on the street that have like a little pole that kind of sits with a little round thing on top? You guys know what I'm talking about? You ever seen the ones where like the surveyors like are leaning over and they have like a little laser thing that they're shooting straight ahead? Usually if like they're building roads or they're building a building, you'll have engineers that are out there doing that. Anyway, they can use these exact same things to figure out how tall something is, how wide something is, kind of how much of a change in elevation they are. Okay, so it's it's the real world stuff of how people actually are going to do those measurements. But what we have, angle of elevation, is kind of when you're looking straight out, perfectly horizontal. Angle of elevation is how much it goes up. Okay, so how much it raises up from looking straight out. So that's what this angle of elevation is, just how much is it when you're looking up. Angle of depression is if you're looking straight out, how much is it going down? All right, the easiest way to remember this one is think of like with angle of depression, when you're depressed, usually you feel kind of down, right? Yeah. And then maybe not you guys, maybe it's just me that's been depressed. But if there's an angle of depression, it's when you're feeling down, or sorry, when you're depressed, you kind of feel down. Angle of depression is when you're looking down or it's going down. Okay? So that's the difference between the two. Elevation is how much you're looking up. The angle of depression is how much you're looking down. Okay, you don't have to write all that definition, but that's kind of the real short and sweet part of how to do it. The stuff we're doing today, they are all going to be story problems. But you know, right now, they're not difficult story problems. The most important part, the part that's going to make you succeed or not succeed, is to draw a picture. They don't have to be good pictures, they just need to be a picture. So this very first one I will do with, or actually, we're going to do 3 of them for the lesson today. Then you guys will have your assignment. And it's, again, not too much. But every single one, draw a picture and it will help. Okay, so this one says, the crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost and it clears the goal by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? I'm going to draw this picture out. That's an eraser, not a drawer. Okay, so I've got this fancy picture. I've got my football here. Here's my goalpost. Okay, it's saying that my goalpost is 10 feet high, and then it wanted us to clear the top of the goalpost by 1 foot. So here's my football. You don't have to draw the football when you draw yours. Okay, it said I'm 25 yards away, and it wants to know this angle right here. Okay, it just wants to know how much of a degree does it need to get kicked up to go over that. So the first thing I'm going to do is I'm going to simplify these things down to make sure that they're all the exact same labels. And then I can buy anything that I have. So right now, one is saying feet, one is saying yards. Let's change them all to the exact same label. Can we change yards to feet? What do you got to do? You can do a conversion or just multiply by 3. Yeah, if you did the conversion thing, it would have got you there. So 25 yards is the same as saying, I'm just going to cross it off, 75 feet. That is multiplied by 3. So we kick this thing from 75 feet away. How tall or how high does he actually need to kick this? Field goal's 10 feet, and he wants to clear by at least 1 foot. 11. Perfect. You just added them together. It's tiny right here. It looks like an H instead of a 1. Sorry. Sorry, that's my 1 foot. I'm not good at writing. 1 foot. Okay, so this is my 11 feet. This is my 75 feet. I got to find that x. Looking at this chart over here, sine, cosine, and tangent, which one will I use to figure it out?
When you're trying to find the x, you have opposite and adjacent. So tangent.
Fantastic. I'll use tangent because I have opposite of adjacent. I'm going to let you know pretty much every single one of these. Maybe one might not. They're almost all going to be tangent. That's my little hint for today's assignment. So yeah, I'm going to use tangent. So I've got tangent of x is going to equal opposite over adjacent. So equals 11 over 75. And then all I do is I solve it just like you did yesterday. What do you think?
This is the regular one, right?
So I don't know this value, so yes, I'm going to use the negative. So I'm going to use the inverse function. So if I punched into my calculator, it would be tangent, or inverse tangent, so it would be tangent to the negative 1, 11 over 75. So once you got done doing that, who has an answer for me? Let's see if I can get up to it. 8.3? Perfect. My degree that I need to kick this at, needs to be kicked at 8.3 degrees. Again, all I'm doing is I'm just using that sine, cosine, tangent, and you're just putting in the numbers that you know. Majority of this assignment is going to be super duper easy. There's going to be one difficult one that I throw into the mix, but we're going to practice that one as well. Questions on that first one? Okay. Example number 2. At the circus, a person in the audience is at ground level. They're watching a high wire routine. A 5 foot 6 inch tall acrobat standing on a platform that's 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 feet? So I'm going to draw this fantastic drawing again. Here's me sitting down in my chair. Okay. So here's the platform. Here's my acrobat. Then I'm going down to there. All right, so after I drew my picture, I'm going to start putting some stuff in there. But we're going to talk each one of these ones out as I drew it. So here's the distance from me to the platform. This is the platform. Here's how tall the person is. Okay, it says the angle of elevation is 27 degrees. Will I put that here or here? Here, how about this? Choice A, choice B. Choice A, it's going to go down here because it's angle of elevation. He's looking up. So 27 will go down here. So 27 degrees. Okay, let's put the information that we know. It says the person that's standing on the platform is 5 foot 6 inches tall. Can I write that just using feet? 5.5. Yeah, 5 foot 6 inches is 5.5 feet. Okay, how tall is the platform? 25 feet. Okay, and then it says it wants to know how far we are from the base of the platform. So I want to know this distance here. If I don't know it, I'm going to give it a variable. Okay, I've got my stuff there. How tall is this platform with the person? How'd you get 30.5? You're right. Yeah, just add them together. So 30.5 is my height. I have my variable of x. I have 27 degrees. Which one am I going to use? Sine, cosine, tangent. Do I have a hypotenuse? If I don't have a hypotenuse, which one does it have to be? Has to be tangent. So as I write it, it'll be tangent of 27 degrees equals my opposite over the adjacent, so 30.5 over x. And now it's just like yesterday when you solved it. Okay, I'm going to use a different color pen so I can show all the stuff I'm doing. So I want to get the x on a side by itself, so I multiply by x here times x here. So now I get x times tangent of 27 on this side equals 30.5. And then I want to divide both sides by tangent of 27. And then I get for my final answer, x equals 30 divided by tangent 27. Oops, stop it. Sorry, 30.5 divided by tangent 27. Should have ended up with an answer of 59.8 or 59.86, or you could say 59.9 because it rounds it up.
Why don't you use negative 1 for that one?
Because it gives me the degree. Yep, if it gives me the degree, I have to put it in here. If they don't give me a degree, I use the inverse. So far, so okay? Okay. Here is going to be the trickier one. I drew out the picture already to start with. My suggestion would be to write this one down because this will be like number 9 on your assignment. And this is the one that got tricky for some people. And this is kind of like where they use like the real life examples of doing this stuff. For it's not 3, I called it 2.1 because I jumped in the middle of it. The rest of them are super easy. So this one that talks about Annabelle and Rich, that's what I'm talking about. Biggest thing I want you to do is just draw that picture so that way you can see what's going on. All right, so it says Annabelle and Rich are setting up decorations for the school dance. Rich, that's it right here. He's 5 feet directly in front of Annabelle under a disco ball. If the elevation from Annabelle to the ball is 40 degrees, this spot right here, from her to the disco ball is 40 degrees, and Rich to the ball is 50 degrees, from here up to here is 50 degrees. I want to know how tall the disco ball is. Okay, I'm going to show you all the steps and how we're going to be able to figure this one out. I'm giving you a chance to draw your pictures, that way you can use it when we go. Okay, so I'm going to start writing some stuff down. Do we know how tall it is from the ground to the top of that disco ball? No. If we don't know it, what do we give it? A variable. Yep, we're going to give it an x. All right, here's the next part. Between Rich and the base here, directly underneath the disco ball, do we know how far this is?
Yeah. No.
We don't. If we don't know it, what do we give it? Another variable, but we can't use x because we've already used x. So I'm going to use y. But yeah, if you wanted to use j, you could use that. We're going to give 2 separate variables though. So my height is going to be this one. The distance between Rich and the bottom is going to be y. Here is how we will set this one up. So we're going to have kind of 2 separate things that we'll need to do. Zoom out just a smidge. So when I'm trying to solve for Rich, and I'll put a Rich there, I'll put an Ann there instead of Annabelle. I'm gonna use tangent, okay? Because I have opposites, I have adjacents, but I don't use the hypotenuse at all. So when I set it up for Rich, how would I set up my equation to solve for this tangent with Rich?
Tangent 50.
Yep. Yep, equals opposite over adjacent, so equals x over y. Again, I know there's two variables there, but it is set up because it's opposite over the adjacent. So that's how far it is for Rich. For Ann, how do you think I'd set up at least the starting part for Ann?
Tangent of 40.
Mm-hmm.
Would it be then x over 5?
Close. So I've got tangent of 40 equals x over, I'm doing that whole distance, so it would be 5 plus the y, because it'd be both of these parts. It'd be this part here plus this part here. So I'm going to write it with the addition sign in between it. So I've got 5 plus the y. Okay? So here's the distance here for Rich. Here's the distance here for Ann. The nice thing about this is they both have the exact same variables. Channeling your inner algebra stuff that you did last year, we can use substitution to figure these ones out. If we can set them both up to equal x, then we can substitute that information in and solve for it. So I'm going to actually draw lines on, I'm going to use my lined paper because I have found out that I'm not very good at drawing things in straight lines. All right, so let me get another color pen. All right, so for this stuff here, I'm going to zoom in as best I can. For Rich, I'm going to convert this thing into kind of a decimal and just solve for x. I'm going to get x on a side by itself. So tangent of 50, I can put that on my calculator. Tangent of 50 will give me a decimal. So I have 1.19 equals x over y. I want to get x on a side by itself, so I'm going to multiply both sides by y. So I get 1.19y equals x. Again, I just got the x on the side by itself. The rest of that stuff is over there. Now, if I'd like to, I can plug that information back in. So the next part, tangent of 40 is my next equation. So I got tangent of 40 is going to be 0.839. I'm going to use 3 decimals just so that way I'm closer. We know what x stands for, right? I can put that in right now. Okay? Equals 1.19y over 5 plus y. Okay? I want to get rid of this from the bottom. So if this is on the bottom, how do I get rid of the denominator? Multiply, yeah. I'm just going to multiply both sides by the reciprocal. So I'm going to multiply this side by 5 plus y. I'm going to multiply this side by 5 plus y. These ones cancel out. I've got 0.839 times 5. So I've got 4.195 plus 0.839 y equals 1.19 y. Now I'm just going to go through and I'm going to solve for those variables. So I've got 1.19 minus 0.839 I got 4.159. So I minus this one, 839. So I'm showing you what I did. So I got this equals 0.351 y. Now I'm just going to get this y by itself. So divide both sides by 0.351. 0.351. So I've got this one divided by 0.351. My y value equals 11.95. So if I were to plug that back in, it says this one right here is 11.95. Is that what I was looking for? No, I have one more thing to do, right? I know this, I just need to figure out what the x is. So I can plug it back into this equation here. So tangent of 50 equals x divided by 11.95. Plug it right back in. So I've got, I'm just going to write it with a decimal. So I already had 1.19 equals x over 11.95. So I just get to multiply both sides by that 11.95. My x value equals 14.2. This one, this here. Oh, right here. I took 5 times this, and this times this. I distributed the stuff in the parentheses here. So it was 5 times the 8. I'll draw it with another color. So when I did those numbers, good question. I took this part and I distributed, and I took this part and I distributed. And that's where I got 5 times 8, or 0.893. That's where this one came from. That was my first part. And the next distribution was where this one came from. So this one times this was this. Y times this was this. Okay? Again, I gave you one of those types. I just want to make sure you guys are able to see how they do it in the real world. Your assignment, though, page 583, 5 through 13, just the odd numbers.